Welcome to Lesson 7A. In the next preview assignment and in the next class, you'll need to be able to read and create pie graphs. And I'm going to mark, and it's going to go not too crazy, but read and create pie graphs. Pie graphs are used to represent percentages of a common whole. It's very useful with resource allocation. One of the most common tools is using it for budget. And most class syllabi probably contain a budget that describes total points for the different assignments and how they're allocated. Go ahead and read through this piece. I'll hit some of the highlights and even start looking at question number 1 and then come back. Pointing out a couple of highlights in Dr. Latour's quantitative reasoning class, his students can get, or her students can get, 500 points. And they're earned in various categories, and they're displayed in this table. Always, when you get a chart, look at what's going on, what the titles are, what some other subtitles are. Percentages can be visually represented in a pie graph. It is used for resource allocation, and each category has a sector, and that fills the circle as a proportion. For example, Dr. Latour assigned 10% to be homework. And so a homework wedge or sector would have to be shown as 10% of the circle as seen on the following graph. So hopefully you've already looked at question 1 and already worked on completing the pie graph to include the other 4 of the activities. Shade in, label the appropriately sized sector for each of the remaining activities. And as an aid, they divided this into 10 equal sectors. So I'm looking back on the chart that was at the very beginning of this lesson. And when I'm looking at the chart, it mentions that exams are 60%. Homework is 10. That's the one that's represented. Class participation is 10%. Class participation. And then there is a semester project, and the semester project is worth 20%. So we have been asked to complete the graph and include the other 4 activities. It doesn't matter where we put them, we just need to size them appropriately, like class participation. Class participation is also 10%. Semester project is 20%. So I'm going to use 2 of the sectors, semester, project. So we've done homework, class project, class participation, semester project, and that leaves 60% for exams. That should mean that we have 6 sectors left, 1, 2, 3, 4, 5, 6, and this very large portion is going to be completed as our exams, which will represent 60% of our grade. Of course, percentages and data are not always pretty multiples of 10%. In general, a pie graph, in a general pie graph, a percentage is represented with a sector of a circle whose central angle is the given percentage of the 360 degrees. So for example, 20% of 360 degrees is 72 degrees. So that would represent 20% of the total, and it would have a central angle of 72 degrees. Go ahead and hit pause and do all of question 2, and then come back and we'll work on it together. Question 2 states, for each of the following percentages, determine the equivalent central angle in a pie graph and round your answers to the nearest tenth. So it is asking central angle 36% of the 360 degrees. I'm typing in 0.36 times 360, and I'm getting 129.6. and they asked us to round to the nearest tenth, so it would be 129 and 6/10 degrees. I'm going to do just one or two more of these, and then I'm going to fill in the chart, and you can look at it from there. But 21% of or times 360. I'm punching in 0.21 times 360 equals, and I see this on my screen. And if it's to the nearest tenth, then we're already there with 75 and 6/10 degrees. I'm going to fill in the rest of these and then display them so that we can check our answers. I've put answers for C, D, and E on the screen. Look at those, double check those, and then go on and you work on question 3. Hit pause, and when you're finished with question 3, come on back. There are several things going on question 3, like drawing line segments so that we can match percentages and angle measures. They ask us to round angle measures to the nearest degree, and drawing line segments to match up with the angle measures on the actual pie graphs. So looking at our percentages, 33%. So 33% times 360, 0.33 times 360, and they asked us to round to the nearest degree. I'm getting 118.8, which is about 119, but what I think they're getting at is that one's going to be 120 degrees. 0.25 times 360, 0.25 times 360, I'm getting 90 degrees. That one's there. And just to make sure, 0.17 times 360 is 61.2, which is the 61 degrees. Now they want us to look at these angle measures and match them with what they would look like on a pie chart. And I'm going to go for nice and easy here with the 90 degrees, and that's a right angle. And I always keep in mind a right angle because something smaller than it is going to be down here. Something larger than it will be up there. And so if I'm looking at 120 or 61, if I impose a right angle right here, this is less than it. This is going to be my 61 degrees. We're approximating. And in this case, if I impose a right angle, we've got something that's more than. And so the 120 degrees is going to land there. And this one's also a nice one that it's some nice thirds where I can do the 120 in each of the sectors. And then even to point out that the 90 degrees, there'll be 4 of those. On question number 4, if you haven't already paused and taken time to look at 4, and you may want to go ahead and look at 4, 5, and 6, or at least 4 and 5, work on those and then come back and we'll do those together. On question 4, Dr. Latour decides to drop the semester project. And the semester project was 20% of the QR class. Exams are going to stay 60%, and class participation is going to remain 60%. So we need a new graph and a new percentage for homework. Homework was 10. It's going to get what was formerly for the semester project. So now we're looking at a 30%. So to draw something, we're going to have, like our exams, we're still about 60%. And then our class participation may be an easy one to draw. 10% for class participation. And then that leaves 3 of the sectors, which will end up being 30% now for homework. The question for question 5 is below this pie chart, and it says the total budget in 2016, and it's telling us this is the federal government 2016 and the percentage breakdown. The question is saying the total budget was 3 and 54 trillion dollars. How much did the federal government spend on national defense, which was 15% of the $3.54 trillion, and that they just want to know how much was spent. So depending on the power of your scientific calculator, or if you want to do things by hand, or how you want to go at this, I Did this one a lot by hand, in that if we're at 3.54 trillion, then this is getting, and I can go backwards, hundreds, or excuse me, thousands, millions, billions, and trillions. So here is an expanded form, or the standard form, for 3.54 trillion. And then it was asking us to do 15% of this. I did punch this in my calculator, and this did come out to be, here we are, 531,000,000, 000,000. Another way to write this would be 531 thousands, millions, billions. And a different color choice probably would have been a great idea without the S. So $531 billion were spent on national defense. I don't have a spreadsheet as this says on question 6 for Harvard University. However, computing the appropriate angles and drawing the sectors could be difficult and tedious, with it involving lots of minute or large percentages. Anyway, what I want to do is to look at what we are given here on question 6, where it mentions exams, homework, class participation, semester project. And I know on this one it asks us to create one for Harvard University, but I want to go ahead and just use the information right here in front of us, and let's create a pie chart. So all I did is I took this information on activity and points possible, and I opened up an Excel spreadsheet and recreated the information that we are given. I then highlight the information of the activities and the points possible, and I go up, click Insert, click Recommended Charts, and probably a pie chart is going to pop up. So I click OK, that's what I want. A good chart title, just by clicking on it, it's going to allow us to type in information. And in our case, we could call it, I don't even know what we can call it at this point. We'll just call it a chemistry grade. It's Dr. Latour. Grade pie chart. Not a great title, but it gets the idea across that the exams are down here in blue and represent the largest percentage, and then the other parts fall in accordingly. This concludes our lesson 7A. Check your calendar to see if we have any more lessons due this week, and I'll either see you on another lesson this week, or I'll see you on the next lesson for next week.